Okay, here is the question. The first step, we are going to highlight some of the useful information. A shopping cart is rolling forward at 2.5 meters per second, which means we have an initial velocity. A person gives an extra push, which implies that the final speed should be more than the initial speed. Thus, the system should accelerate. The later information provides a constant acceleration at 1.8 meters per second square during the time of 3 seconds. Logically, we will conclude that the cart, the system, will travel faster. Therefore, the question is asking about the new velocity of the shopping cart. This visualization and listing some of the clues with the illustration should be your first step. Then I will reorganize some of the given clues, which means variable and constant. The reason for the reorganization is to identify which formulas would be the best fit. Remember, we have to choose a formula that has only one unknown variable. Since the acceleration is given, plus it is one-dimensional, aka there's no angle, that means you can use a simple acceleration formula that has velocity and time. The fact that you have delta, which implies that it is the differences of a certain quantity, I can definitely change delta V into final minus initial. Boom. Now notice that I have acceleration, check, initial velocity, check, and time. The only variable left over is final velocity, which aligns with what the question is asking, the new velocity. Now we are going to isolate for the unknown variable, in this case the final velocity, which means we're going to multiply delta t on both sides, followed by addition of my initial velocity. Then I get final velocity is equal to acceleration multiplied by time plus initial velocity. We are at the last step, which is substitution. We substitute accordingly what we have, which is acceleration, time, and initial velocity. Notice that all of them has positive sign because we do not have any opposing motion. I always do unit analysis first. Because the question is asking about the velocity, I should have meter per second as a result. After the cancellation, I found that meter per second is the only thing that is left out. Thus, only thing we gotta do is, using a calculator, 1.8 times 3 plus 2.5. As a result, the quantity we have is 7.9 meter per second. But don't forget, this is a vector situation, so we have to put our direction. Boom, here's my final answer, which has direction in addition to the quantity. My final statement for this question can be like this. The new velocity of the shopping cart will be 7.9 meter per second forward direction. See you next time, yo!